this whole concept of brain plasticity. It has many facets, and so we're trying to understand it from whatever angle will afford insight as to how this process works, why it works, how we can take advantage of it, how we can manipulate our knowledge to leverage our abilities to make other processes work in a similar fashion. You know, brain plasticity had been going on for some time in his research, but it kind of hit a wall in that Paul was thinking way past the horizon. And the horizon, you know, the technical obstacles of reaching that horizon prevented much progress. Paul was still very much thinking well beyond what technology could afford. And so basically he had to wait for about 20 years for the technology to catch up with what he envisioned in his mind and his understanding of what's possible, what could we conceivably do. He conceived of it, but we just, you know, it took a number of us, you know, the last 12, 15 years really to understand the concept, identify the appropriate technology where it exists, and develop the technology that doesn't exist in order to bridge this gap between the idea that we have this highly malleable neural process which then is able to take information from alternate information sources, the whole idea of substituting information from one sensory modality to another, and present that to the brain in a way that it can interpret meaningfully. That's been the gap. This chasm has been in trying to take information from one modality to another and make it useful. The cane works because it uses an intact source and it's not terribly sophisticated. It works well in that modality, but when we try to take information from the visual mode or the auditory mode or the vestibular mode, it's a more complex source of information. And so the trick has been in trying to figure out how do we take that information, repackage it basically, re-encode it in a form that we can then give to the brain through the sense of touch.